For centuries, the sun remains one of the greatest mysteries in our solar system. What powers its incredible energy? What triggers the solar winds? And how do its deadly flares reach across millions of miles, sometimes impacting life on our planet? To answer these questions, we needed to do the impossible: send a spacecraft into the sun's atmosphere itself. This is the story of NASA's Parker Solar Probe, the mission to touch the sun. But why would scientists want to go so dangerously close to the sun? Well, the sun isn't just important for providing light and warmth, it also produces solar wind, which can disrupt our communication systems, GPS satellites, and power grids, and they even affect astronauts in space. Understanding how the sun produces these winds could protect us from future solar storms. In addition, scientists wanted to explore the sun's mysterious corona, the outermost part of its atmosphere. While the surface of the sun is about 5,500 degrees Celsius, the corona, surprisingly, is millions of degrees hotter. How could the outer atmosphere of the sun be hotter than its surface? And so the idea was born. We needed to send a spacecraft closer to the sun to unravel the mysteries of solar winds, the corona, and the sun's magnetic field. Building a spacecraft to touch the sun wasn't an easy task. The sun is an incredibly hostile environment, and any ordinary spacecraft would be vaporized by its heat and radiation. But NASA's engineers rose to the challenge. The Parker Solar Probe is named after solar astrophysicist Dr. Eugene Parker, who first proposed the existence of solar wind in 1958. The probe was designed to withstand extreme heat, radiation, and the challenges of flying through the sun's outer atmosphere. At the heart of the Parker Solar Probe's design is its heat shield, officially known as the thermal protection system. Made of a carbon composite material, the heat shield can withstand temperatures up to 1,377 degrees Celsius. Behind this shield, the rest of the spacecraft stays cool at a comfortable room temperature, allowing its instruments to function without getting fried. The probe is equipped with a number of instruments designed to measure the sun's electric and magnetic fields, solar winds, and energetic particles. One of the key instruments is the Fields Experiment, which measures electric and magnetic fields in the sun's atmosphere, helping scientists understand how energy flows through the corona. Solar panels are used to power the spacecraft, but they're retractable so they can tuck behind the heat shield when necessary. Additionally, the probe's cooling system uses deionized water to keep critical components cool, an incredible feat considering the temperatures we're dealing with. On August 12, 2018, the Parker Solar Probe launched aboard a Delta Avor heavy rocket from Cape Canaveral, Florida. It was one of the most powerful rockets ever built, and it had to be, for the Parker Solar Probe was on a mission that no spacecraft had ever undertaken before. The probe's journey to the sun isn't a direct one. The sun's immense gravity means that slowing down to get close to it is actually one of the hardest things to do in spaceflight. In fact, the Parker Solar Probe is the fastest spacecraft ever built, reaching speeds of up to 700,000 kilometers per hour during its mission. To achieve its goal, the Parker Solar Probe uses a series of gravity assists from Venus to slow down its approach to the sun. These flybys help the spacecraft gradually spiral inward toward its target, reducing speed and allowing it to get closer and closer to the sun. By November 2018, just a few months after launch, the Parker Solar Probe made its first close approach to the sun, passing within 15 million miles of its surface, closer than any spacecraft had ever been. As the probe continues its mission, it will get even closer, flying as close as 6.1 million kilometers from the sun's surface, about 7 times closer than the planet Mercury. At this distance, the sun's heat and radiation are more intense than anything we've ever encountered, but the Parker Solar Probe is designed to handle it. During its closest approaches, known as perihelions, the probe collects data on solar winds, magnetic fields, and the corona. This data is then sent back to Earth for analysis, providing scientists with insights they've never had before. Since its launch, the Parker Solar Probe has already revolutionized our understanding of the sun. One of its most groundbreaking discoveries is the switchbacks, zigzag-shaped magnetic structures in the solar wind that were previously unknown. Additionally, the probe has helped scientists understand why the corona is so much hotter than the sun's surface. Each new close encounter brings more data, more mysteries, and more opportunities to understand the star that powers our solar system, but the mission is far from over. The Parker Solar Probe is expected to complete 24 orbits of the Sun by 2025. With each orbit, the spacecraft will gradually get closer, ultimately flying within just 3.8 million miles of the Sun's surface. As it continues its journey, the data it collects will help scientists protect Earth from solar storms, refine our understanding of stellar physics, and potentially unlock the mysteries of stars beyond our own Sun. The Parker Solar Probe represents one of humanity's most ambitious space missions, a daring attempt to touch the Sun and uncover its secrets. From its advanced design to its record-breaking speeds and incredible scientific discoveries, this mission is a testament to our relentless pursuit of knowledge. So next time you look up at the Sun, remember, there's a spacecraft up there, flying closer to it than anything ever has before, all in the name of discovery.